Now, I saw a post on the home recording forum, one of those, that said, cables, the bane of my life. And I went, oh, okay. So there could be two things, either lots of tangling, or they go wrong, or there's a problem with them, not reaching, or too short or too long, or whatever. And I thought, well, it'd be high time for me to sort of talk about connectors, cables, and things like balanced, unbalanced, that sort of thing, and capacitance of wires, because it makes a massive difference in your studio if you've got the cabling right. I know lots of people forget about cabling and think, oh, I've got this bit of gear. There's nothing to connect it with. However, all of that can be addressed. Now, I'm just going to go through a couple of the connectors that we all know about, and then talk a bit about sort of balanced and unbalanced. So, to start with, we've got this, the humble jack plug. Now, this was designed in the 1870s. Of course, a slightly different version to this, but must mean there's quite a lot right with it. And it's used for the interconnection of guitars, keyboards, mixing desks, you name it. There's bound to be a jack. They're even used for speaker cables. So, this one here is a stereo jack because it's got a tip, a ring and a sleeve, so it's also known as a TRS. So if you see TRS written, you think, well, what's that? That means it's one of these 1/4" jacks. We've also got the mono version, which is this, which has just a tip and a sleeve. There's no ring in the middle. You can see the difference between that if the light catches it right there. So I'm going to just talk a little bit about the jack plugs. Now this one, this particular lead that I've got here has a mini jack connector. Now, the large ones, they are 1/4" or 6.35 millimeters. And then we get the smaller version, which is this, which is the 3.5 millimeter version. Some people call it 1/8 of an inch, but it's not quite. It's a little bit bigger than that. So it's essentially used for headphone outputs. It's more of a domestic, that is, consumer format. Now, that leads me on to the next connector here we've got, which is this. Let's put the others to the side. This here is the RCA phono jack. RCA after Record Corporation of America. And it's also, in some circles, known as a cinch, C-I-N-C-H, although that is a slightly archaic term now. Now, it's used, really, it was devised in the 1940s to act as interconnection of internal components, things like radios, and it's still used to connect spring reverbs inside guitar amps. So you'll see your cables coming out with a phono in and phono out, and that's fine. But one thing I really don't understand, I really don't get this, is why the output of a DJ console still resolutely phono. I don't get it, because they are actually not very nice things. They are really just cheap. It's just connection of cheap kit. So, and they are an unbalanced connector, and I'll talk more about that in a minute. Now, the other classic one that we've got is this. This is the XLR connector. We've got a female and a male. Now, how that works is, well, this is the only one really in common use that has a female and a male connector that isn't sort of built into a piece of kit. I mean, jack connectors are always female when it comes to connecting, whereas XLRs are both female and male. I have a cable tester here. This is a pretty useful bit of kit to have. You can test everything, mini jack to phono to jack to MIDI to even speak on. Now, the XLR, the only difference between this side and this side is the fact that the XLR gender is different. So you can get XLR sort of gender changes, so you have a male to male or female to female, but you've got to ask yourself why you need something like that, because the outputs of things are always, on XLR terms, male. Now, that includes a microphone, for example. If I've got a mic over here that's got an XLR output, and the idea being that you then plug your female into that. Fine. Now, balanced and unbalanced. What does that mean? I'm going to show you. So, first of all, with the aid of a piece of paper, I'm going to draw what happens when you send a single signal. So this is an unbalanced signal. So we've got that line represents silence. It could also represent the cable that is travelling down. And your signal will do something like this down the wire. There we go. Everything's lovely. It's sending a positive signal and then a negative one. Now this is basically how sound works. Sound is a disturbance where you get positives and negatives. You get pressure outwards and pressure inwards. And a speaker, if you've ever seen a bass speaker moving really sort of a lot, it will be going in and out like that. So it's exactly the same as this diagram here. Now, the signal is travelling this way. So we've got our CD player or whatever it is, or guitar or whatever, and then your amplifier this end. Now, that's fine until we get problems with interference. Now, let's say there's a sudden, a sudden lighting, a lighting fitting changes, or the fridge clicks in and out, or whatever it happens to be, any interference. And for the purposes of this demonstration, I'm actually going to just put it as a single spike. Interference is sometimes noise which manifests itself onto the signal like that. So that's high frequency content like radio waves or anything. It could even be low frequency modulation, so your signal becomes unbalanced by something else like mains, which is only 50 hertz. So I'm going to imagine then that at this point there's a sudden spike on the cable, on the signal rather. So the signal actually does this. It goes, and there's a sudden spike before it carries on. So imagine that is not there like that. That's going to get amplified, and we don't want that. This is where balanced lines come into play. So this time I'm going to, so an unbalanced cable has only one central connector at which your signal travels down. There's also a ground or a sleeve, and we're going to ignore that for the minute. Basically the purpose of the sleeve, the ground wire on a cable, is to try and minimize the resistance, minimize the effect of your interference, in that the ground wire is grounded both ends and it's meant to be a shield for your middle wire. In practice, that's great, but in reality, it doesn't always work so well. Now, I'm going to now draw this, where your signal is going in what's called antiphase. There we go. So there's my interference that we had on the other line. Now, actually, what happens in practice, just before I carry on and make a mistake, is that the interference looks the same on both lines. So ignore that bit there. Now, this is your other connector, which goes inside your XLR. You remember just now I showed you the fact that there are three connectors, three holes there. You can see it a bit easier there with the 3 pins. Now, pin 1 is always the ground wire on an XLR, always. Now, I'm going to, with the aid of another piece of paper, show you how this essentially works and the advantage of balanced over unbalanced. Now, this is essentially the output of a mic. So that's how this works. You've got your microphone, you speak into it. The signals, there are 2 signals that travel down the wire. One which does this, and the other does the exact opposite, the mirror image. Now, when you get to the other end, these 2 signals go into your XLR input. Now, your XLR input is like this. You've got the cables like this, where you have 1, 2 and 3. Can't remember offhand if 1 and 2 are the opposite on an XLR connector, but the principle is the same. So pin 1 is connected to ground, or from the camera's point of view you can imagine it that way. There we go. So that is to the case or the screen or the earth or whatever it is. Pin 2 has one of these signals, and pin 3 has the other. So let's imagine that this XLR is part of your circuit. So pins 2 and 3 now go to your amplifier section over here. Now, as before, we've got this. So that's one bit of your signal there, and the other bit, as you remember, was out of phase, was completely mirror image. Now, on one of the lines, we get an amplifier. That's a circuit diagram sort of notation for an amplifier, a triangle on its side. And we're going to have a -1. Sometimes it's known as the Greek letter theta, which is that. Now what that means is that it's going to turn this round to this. It's going to switch that round, and it's going to turn it into one of those, which is the same as we've got on the other wire. Now in maths terms, 1 plus -1 is 0. Give and you take back. 0. Net gain of nothing. And that's what we've got here. Now, when you turn one of them round, we've got 1 plus 1. 2. We've got our signal back. What does this mean for our interference though? Well, if you remember, the interference, the line, the mic cable, I'll just grab the cable wherever I've put it. There we go. I'll just there it is. Now, this is the XLR cable. So we've got our microphone one end plugged into our female XLR. So there's our source over here, and then the line goes along like that with 2 cables inside. So that's one cable and that's the other. And then at the other end, we've got our XLR here, which we're plugging into our amplifier. Now, the interference is going to come from the ether, and it's going to affect both wires at the same time, because that's how it works. Inside we've got those 2 connectors right next to each other. So any little spikes are going to manifest themselves on the line in exactly the same direction. So it's moving upwards here and moving upwards here. Okay, that means that our interference, if we draw that here, there's our interference that we don't want. So that's a problem. We don't want that on our line at all. However, when it gets through the amplifier, through the one side that turns everything round, we end up with this and this. So we got +1 and -1. And there we have it. Your interference is cancelled out by the amplifier because we turned one of the signal wires the other way. And there it is. Now, some amplifiers or mixing desks or in the specifications will have something called common mode rejection ratio. What? It's basically how well that does, how well it does this. So moving on, there's our balanced and unbalanced. We also have things like multicore cable. Now this cable, this is very old cable. I got this when I was working for EMI back in the 90s. They did a reinstall of a studio, and they took all the multicore cable out. And I said, oh, can I have some of that? So you can take as much as you like. I went, yay, nice. So this cable is probably 1970s. It's fine, there's nothing wrong with it. Beware of the people that try to sell you oxygen-free copper. The answer is copper oxidizes the moment it's produced, albeit very slowly. But all this stuff about oxygen-free copper, I don't understand it, don't get it. It doesn't make any sense. Now, what I've done here is, if we look at here, I've got 16 jack plugs. Why have I got 16? Well, it's the output of a hard disk recorder, and this is the mixing desk end. Now what I've done is I've cut all the cables to a certain length, which means you never ever have any tension on your cables, because everything sits nicely and plugs in to the mixing desk like so. So the wire comes along your desk. Let's take the balanced and unbalanced out of the way. There we go. Everything sits nicely on the desk, and there's, sort of, you know, 3 wires. Now this stuff is foil wrapped, so it doesn't have the individual connectors. So this is really designed for installation only rather than live use, for example. And what I've actually done is I've put some sort of heat shrink sleeving round each one. I'll just get rid of the spares round each one to stop it sort of unfolding. So we've got 1, 2, 3, 4. There's your 5 and 6, 7 and 8, and then etc., all the way up to 16, like that. This means that none of these channels are under any stress at all. Now I've done about 50 recording studio installations, and I've yet to receive a call from any of them saying that any of the cabling is broken, because I always say, if there's any problem, give me a ring, I'll come and sort it out. I haven't had a single phone call. Now, of course, I'm not trying to sound sort of big-headed here, but I really take a lot of care with this to make sure that cables are really not the bane of your life. So the other end of this is a similar thing, but with phono connectors. Now, my multi-track recorder has phono outputs, which is not ideal. You can buy the card as like a circuit card that has balanced outputs, but I didn't opt for that. So I would have done, however, if I'd had the money and also had the, you know, the sort of really the warrant, you know, the case for it really. But what I've got here are 2 pairs. I've got channels 1 and 9, 2 and 10, 3 and 11, wherever 11's gone, can't find it. I think it might be that one, 4, etc., etc. And I've numbered my cables as well. So that means that my hard disk recorder, which is 2 rows of phonos, 1 to 8 and then 9 to 16, are also catered for in this method. Now, what you do is essentially this cable, multi-core cable, by default comes as balanced cable. It's not necessarily a problem if you're just using unbalanced. It's a bit more expensive, but it does allow you an upgrade later on, especially if you leave enough of this cable that if you maybe bought another machine that was balanced, you could rewire this. So beware of buying just unbalanced multi-core. You can buy it, and if you know that it's just going to connect up a sort of a small mixing desk with the output of maybe a reel-to-reel recorder that is only phonos, then that's fine. You can use unbalanced cable. So what you have inside here are 2 connectors, or 2 wires. Now I've done a workshop on fixing mic cables and all that as well. Now we have here a grey, a white and a shield, or the screen or ground. Now what that means, there are lots of different colour combinations, and this particular cable has a list of channels where channel 1 is red and blue, and then channel 2 is red and orange, red and yellow, red and green, etc. And then you have another colour that swaps over with the first one, meaning all the combinations are possible. So we've got the ground wire here, and then your 2 signal wires. And how that works is that when you put them onto your XLR connector, wherever I put that, there we go, undo the connector, take the screen and take the shield and the thing off, and then there we go. There's my XLR connector. We have got 3 pins there. There is actually a 4th, like a ground tag, but we don't use that. And then you put your cables on like so with your soldering iron. What I tend to do with this is to shorten the ground wire ever so slightly. One reason for that is that there are more strands on the ground wire than there are on the signal wires, and therefore it's a bit stronger. So if I make the ground wire shorter, for example, if I just fold that over and put that onto pin 1, it means that my other 2 cables can have a little loop before they finally attach onto this, which means that they are under no stress whatsoever. And the way that an XLR connector works is that you get strain relief, where you can put this, you put the connector back together, and then this here, this little conical piece of plastic goes in there, and as you tighten this up, it squeezes that little conical connector against the cable, and that's kind of how it works. So there is how to do an install. You need to cut your things, cut your wires to shape, cut your cables to shape. So before the connectors go on, you have a sorry, for example, if I'm using these four, and you've got your mixing desk connectors, which are kind of, let's say you've got this, 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 and this. You bring your cable up like that. You measure this one, ideally slightly past the jack so that there's a bit of room, because you don't want also to have not enough room this end so that you're having to try and put a jack plug on, you know, without taking enough of the outside sleeve off. So you'd have this one to go to here, then you cut this one about there to go to that one, cut this one to about there to that one, this one to about there to that one. And that's how you do it. If you do that on all of your studio installs, any bits of kit that you own, assuming of course that you've finalized where you want to put everything, it's a really, really good idea to do that. Now, little word about cheap cables. Now, one example of that is something like this, where we've got two phono connectors one end and a stereo jack the other. These are the sort of cables that you get free with a hi-fi, or you get free with a hi-fi, I'm showing my age now, or you get it with an iPod or a phone or whatever. Commonly, they come with a small headphone jack one end and then two phonos the other. Now this is the sort of mainstay of sort of hi-fi in the 1970s to kind of present day, really. If you've got like a digital radio, it might have a aux in where you can connect an iPod. Aux in is different from phono in. Record players need a special preamp to work. Now, the trouble with cables like this is that you get things called cable capacitance. Oh, okay, what's all that about then? Well, I'll just briefly show you about that. As we go along a cable, so if you've got your input there, and then your output there, as the signal travels along the wire, copper wire by its very nature has a slight resistance, and that's known, resistance. The symbol for resistance is that, where it's just basically presenting a resistance to your signal. Now, that's your signal wire. So let's pretend that this is an unbalanced cable. Then we've got the screen that goes along. Remember the screen that I was saying more of that in a minute. And this is the one that's connected to your ground. So in terms of your mono jack, for example, it's this. This is the ground wire because this and this are connected, and then you've got your tip at the end here, which is the positive wire. Now, any two wires that run next to each other are going to act as what's called a capacitor. Now, the circuit diagram for a capacitor is this. So it's two metal plates. Now, a capacitor behaves differently according to frequency. Now, this resistor here and a capacitor, this is a little bit of circuit here, this is essentially the tone control on a guitar amp, where you have a variable resistor, which is that, and then a capacitor that's stretched across it. And when you increase the resistance, you lose all your tone. You lose all your high frequencies. Now, the reality of the situation is that the capacitance between the signal wire and the ground wire of a cable is meant to be basically so insignificant that it doesn't cut any high frequencies at all. But the cheaper the cable, the higher the capacitance, and you might end up with a cable that doesn't actually respond to all the audio frequencies that you would fully desire. And that is the reason why you have capacitance between conductors of a cable. So when you are looking at buying cable, look to see under the specifications the capacitance of that cable. And you might even get the resistance. It's usually per meter and it's kind of milliohms or something. It's very, very small resistance. Now, that's kind of about it. Now, things like this, the cable tester, are really useful bits of kit. If I've got my microphone lead, for example, down here, I think it was, yeah. This is about, I think I paid about £25, £30 for this. Really, really useful. When you plug an XLR in one end, there we go, so I'm testing my mic cable now, you can see that pin 1 is connected to pin 1. Great, that's what we want. If I switch this around, pin 2 of this is connected to pin 2 of this, and pin 3 is connected to pin 3. That's fine. 4 and 5 are used when you are testing MIDI cables. Now, a little word about MIDI cables. Now, this is also known as something called DIN. You think, oh, okay. Now, I'm just going to grab a MIDI cable from the rack here to show you basically what it's about. I should have grabbed that before I started this demo, but there we go. Now, MIDI cables is where you have 5 pins at each end of your cable. And you think, well, why is it this? This was what hi-fi was in the sort of 1960s and 70s, where you'd have 5 pins. And basically what that would be on a tape recorder, you'd have left in, right in, left out, right out, and ground. Hence your 5 pins here. But in the 1980s, it was used as a proprietary connector for MIDI because it saves a lot of the development costs. You can say, well, we just use a standard connector that already exists. And that's the reason it's like that. Now, a MIDI cable here, if I test one end of this and the other end, hopefully all the cables will work. There we go. That is good to go. Now, the problem comes if one of the lights didn't light up, for say pin 4 of one of them didn't light up with pin 4 of the other, then that indicates that there's a problem. But hopefully most of my leads work and I haven't actually got a duff one to show you. Never mind. Okay, so that is essentially a bit about cables, about balanced and about unbalanced. Now, the next thing is levels. The lowest signal level that we have at the moment is a mic signal. So the output of my Shure SM58 here might be 10 millivolts. You know, that's very, very, very small. Then we've got things like record players whose outputs are a little bit higher than that. But record decks have a different thing called the RIAA equalization curve, and you do need a preamp. You can't connect a record player straight into a mixing desk. It won't sound very nice. And the next one that we have is an unbalanced jack. Now that's things like guitars, or it could be the output of a keyboard. That's known in the trade as -10 dBu. -10. You think, okay, well, what's -10? It's said to be the consumer operating level. Now you also have +4, which is the professional level. Now the trouble is, if you connect something with a professional level output, +4, into a -10 input, it's going to overload it. Now, the problem I had was my mixing desk over there that I use live to record with had +4 outputs, whereas my little 16-track hard disk machine has got -10 inputs. I thought, okay. So I had to build in 2 little resistors in each connector in order to try and reduce the level. Now you've got to be careful with the values of your resistance, because if it's too low, if the resistance values are too low, it'll affect the output, it'll load the output of the mixing desk, and therefore also, remember my resistor and capacitor network, it would also have an effect on your high frequencies. But I picked values that were high enough that it didn't actually affect the hard disk machine at all. And that brings us on to things like impedances. Now, the output impedance of a piece of kit should be as high, should be as low as possible, so that it doesn't actually, the input, the impedance of your input on your next stage doesn't take too much current away from it. Now I know that's a bit of there are maths sort of equations, things that need explaining. I'm not going to do that here, because essentially what you need is something that is whose output is low enough to drive something else, whose input impedance should be as high as possible so that it presents the most resistance to your output. So guitar amps have quite a high impedance. That's what high Z means on PA systems. If you've got a jack plug that says high Z, it means that you can use a microphone that has an XLR one end and a jack on the other. Now, that is kind of what it used to be like. PA systems used to have jack inputs for your mics instead of XLRs, purely for cost. It was cheaper to build something that had jack inputs than XLRs. Simple as that. So when you have a output of a microphone, you plug your XLR in. On the other end would be one of these, but it would be a mono one like this. And you plug that into your mixer, your PA mixer of the time, and you could amplify it that way. Now, of course, that means unbalancing a balanced signal. Now you can do this if you've got an XLR output of an audio interface and your speakers have only got phono inputs or your amplifier. What you can do is you can join pins 2 and 1. So if I just grab my XLR here we go. Here's your XLR. With pins 1, 2 and 3. 1, as we know, is always the ground wire. Now, in order to unbalance the output of any piece of kit, you simply link one of them, only one, to ground. Now it depends sometimes on the piece of equipment. We call this pin 2 hot or pin 3 hot. You think, what does that mean? Well, pin 3 would be plus and pin 2 would be minus. Now, sometimes it's the other way around. Pin 2 would be plus, pin 3 would be minus. Depends on the bit of kit. So if pin 3 is minus, you would join inside the XLR connector pins 3 and 1, and 2 would be your signal that goes out to your amplifier. Now, always be careful the other way. If you are feeding a mixing desk with a male XLR, let's say you've got wherever it is, can't find it. Yeah, okay. Let's say you're feeding your mixing desk with something like a CD player, but you want to put it into an XLR input. You've got to be careful because mixing desks have phantom power. Now what that means is it applies a high voltage, usually 48 volts, to both pins 2 and 3. Now you can imagine the firework display that may ensue if you short out 48 volts to ground. That's not very nice. You might see fireworks or thin little flumes of smoke coming out of the mixing desk power supply. Now, how you get around that is by using one of these. This is a DI box. This particular one is a stereo version, so this one is a mono version. So you plug your input, your CD player, in here, and then your output goes to your mixing desk as a mic level signal. You can see a video on my channel about DI boxes, and DI boxes are essentially essential. They are essential bits of kit if you've got things like CD players or DJ mixing desks or whatever that you want to connect to a mixing desk which might be miles away down the room. That's where balance signals also come into play, because as I said before, things like interference doesn't really make a difference to a balance signal, which means you can send a mic signal for technically miles before you encounter any problems. That's mostly down to capacitance of cable. Then you get your high frequency stripped off a bit. Now, the mixing desk inputs, XLR inputs on a mixing desk are always mic level. They're not line level. So when you use a DI box like this and you plug a high level input, you can connect a speaker level input into this, which is really high. It'll still turn it into a very delicate balance signal that can then be used by a mixing desk. So I hope I haven't confused anyone with any of this stuff, and I hope that it makes a difference to that person.